Now, this particular book's going to write them a little bit differently. So you guys have always seen, 8 choose 5 or 15p7 or whatever. They're just going to use parentheses here. And they're going to put the n on the top, and they're going to put the r on the bottom. So when you see something like that, it's automatically you're going to be doing a combination with it. Okay, so 8 choose 5 would look like that. Now, you could use your formula for it. You can use your calculator. So we'll do that in the calculator real quick. Okay, 56. Now, the neat thing with these is Pascal's triangle is basically built out of combinations. So we just did 8 choose 5 and got 56. If you go to the 8th row of the triangle, you see a 56 on here. So if you do 8 choose 6 now, you get 20. Oh, sorry, wrong 56. This is the 56 we're looking for. Now, if we do 8 choose 6, we get the 28, which is right next to it. If we do 8 choose 7, we get an 8. If you got 8 friends, how many ways can you hang out with all 8 of them? Exactly 1 way. Okay, so Pascal's triangle is built on combinations. But the only trick was, we said this 56 was the same as 8 choose 5, but it's 1, 2, 3, 4, 5. It's the 6th entry over. So you're always offset 1. So the first one is always n choose 0. Okay, you got 8 CDs. How many ways can you listen to 0 of them? 1 way. Okay, you don't do anything with it at all. So then this is 8 choose 1, 8 choose 2, 8 choose 3, 8 choose 4, 56 is the 8 choose 5. So if I wanted to do 6 choose 4 without my calculator, I'm going right to Pascal's and going 0, 1, 2, 3, 4. Okay, 6 choose 5 and 6 choose 6 are those right there. If I want to do 4 choose 3, go to the 4th row, choose 0, choose 1, choose 2, choose 3. So if I want 7 choose 4, like I ask here, you can do it in your calculator, you can do the formula. Choose 0, choose 1, choose 2, choose 3, choose 4. Okay, so it's another important pattern hidden within Pascal's. If you check that just to make sure, is the 35. Okay, and obviously there's a symmetry in there, and that comes from the formula as well. So the combinations with Pascal's triangle are important because we're going to do some binomial expansion stuff that I'm going to be asking for individual terms, and the triangle may not go that high, or you may not have a triangle that has that many rows, so we want to use that information as well. Here's a little summation formula just to tie it back to what we've been looking at this chapter. If you want to do x plus y raised to the n, you're basically summing all the terms from 0 to n, combinations, and then here's kind of your exponent thing. Okay, so this formula here represents all the stuff we used with something like this. So this would be 6 choose 3, 6 choose 4, 6 choose 5, 6 choose 6. Okay, and you can see the exponents are always going to be 1 off there. And when you take n minus k and the k, and you put those guys together, they cancel, and they should always add up to n. So just like everything here, always added up to 6. Okay, so if I want you to find the 6th term of an x plus 2 to the 9th, the triangle we just had didn't go all the way to the 9th row. You certainly don't want to expand all this stuff out. So here's what we're going to do. I know the first term is going to be an x to the 9th, 8th, 7, 6, 5, and 4. So I know this right here will be the 6th term. Okay, I know it's going to be an x to the 4th. Okay, so that's good. If I know it's an x to the 4th and it has to add up to 9, automatically I know it's a y to the 5th, or a's and b's, however you want to think about these. Okay, now what would the coefficients be? So you could go grab Pascal's triangle and you could find a ninth row. This here, it would be 9, choose 0. This would be 9, choose 1. So it'd be a 1 and a 9, and then I kind of lose it from there because you'd need the triangle. There's 9, choose 2, 9, choose 3, 9, choose 4, 9, choose 5. Okay, so we're always 1 off. Okay, the sixth term isn't going to be choose 6 because we had to start with that choose 0. So the sixth term, 9, choose 5. You can write it like that. You can write it how the book does with the parentheses. I'll call it an A to the 4th and a B to the 5th. So there's my skeleton that I'm going to work with. You can use your calculator for this. 9, choose 5 gets us to 126. Now, what is the A and the B? There's your A, and we're going to let the B be a 2. So we're going to say 126, the A is an X, so we'll just keep that as X to the 4th. Now it's B, which is a 2, and we need to raise this to the 5th. Okay, so we're not going to have X's and Y's because we only have one variable in there. So 2 to the 5th gets us to 32. Multiply it by that 126. 4,032. Okay, that's what your sixth term is. So I'm not asking you to expand the entire thing. That's a lot of work. But just find individual little terms hidden within there. Okay, so if you want to, find the 7th term, find the 5th term, okay, and compare those. One more little practice here. So if you want 4th term of this, okay, Pascal's triangle, the 15th term is going to be a whole lot. You'd probably have to Google image that. So we'll just kind of start with the skeleton here. Okay, so we'll call this A and B. If I want 4th term, well, I know my first term's going to be A to the 15th, and then I'm going to count down from there. Okay, so I found my 4th term. I know it's an A to the 12th. So how many B's does it have to have? It's got to have 3 of them, so they add up to 15. Now, the only problem is I need a coefficient in front of it because I don't have a triangle. So this would be 15, choose 0, 15, choose 1, 15, choose 2. This has got to be 15, choose 3. 4th term isn't going to be 15, choose 4. So I always write it with the combination thing. Just know the book would do. Okay, something like that. So now all we got to do is go plug some things in. $15, choose 3's 455. Okay, what is the A now? Well, the A is going to be a 2x. Raise this to the 12th. B is a minus 7y. So we haven't looked at one with a negative before, so make sure you keep that in there. And this entire thing is going to be to the 3rd. So now it's just a matter of simplifying correctly. You're going to do negative 7 to the 3rd, so your term's going to stay negative there. Okay? So you can see over here in the calculator, I took the 2 to the 12th, multiplied it by the coefficient that would have come from the triangle, and then negative 7 cubed. I lucked out. I didn't put my parentheses around it, but it's because it's an odd power, it's going to stay odd. So here's the number out front. Okay, 639 million there, and then you're going to have the x squared and the y cubed. So you can see why you wouldn't want to, fully expand this entire thing with 16 terms in there. So we'll just ask for individual terms, but that's what you would get. as the fourth term. So even think about the terms in the middle, they would be even bigger, okay, because the coefficients are going to be bigger as well. Okay, so the negative 639 million, make sure you grab the variables with x and y. We will have both of them because that's what we started with. So if you want, see if you can find the fifth term, sixth term, or whatever, and think about any questions you guys have.